Morning, everyone. How you doing today? You ready to talk about hardware? Yeah? All right. I'm John.
I'm Phil.
This is our third time doing this. We also probably hold the record for consecutive WWDC hardware keynotes. So it's great to be back again. Obviously, we're going to be talking about hardware directions today, as the slide says. Now, I know everyone here would love for us to start really having a conversation about the actual products we're developing, all the specific details, and what we all know that's not going to happen today. What we want to talk about is the basic roadmaps, some of the technologies we're working on, and where we're going. The goal is to give you the information you need as developers to make the right choices and the right decisions going forward. So with that, let's take a look at where we are with the roadmap.
And I certainly want to urge that everyone listen closely. The things we say are quite simple, but the things we're really sticking to. Some people have said to me, I wish you had told me that Mac Serial was going away, and I wish I had earlier noticed that you're going to transition to USB. Well, actually, 3 developer conferences ago we said that, and 2 developer conferences ago we said that, and 1 developer conference ago we said that. So we really have been trying to communicate this and make it clear, and we'll do our best to be very straight with you, very direct on the things we are doing and aren't doing. And hopefully next year you'll see that everything we talk about here will have come true and happened and been still the same direction next year.
So if, I assume everyone here is real familiar with the product roadmap. You've probably seen it plenty of times, but let's just take a quick spin through it there, Phil.
So again, we went back to simple 101 on our product strategies to make it really clear from our customers. We used to have 15 platforms for desktops and made it a mess for testing, for bringing up products, for increasing reliability. Now, two lines, desktops and portables. And of course, one of them meets consumer and a lot of the entry-level education grades, and another one professional and the higher ed grades, and that's it. That's truly how we got down to the 4 product lines, and despite the crazy stuff you'll read on some wacky websites, these are the 4 product lines we are working on.
Okay, so the first one we should talk about is the consumer desktop. Of course, you all know that's the iMac. Right? Last week, a year ago, we introduced the iMac, and we actually started shipping it about 9 months ago. It has been an incredible success and has caught the imagination of really the whole world, which is shown by all the countries that you all have come from.
We've seen great success for Apple, and in part, it's due to the iMac. The other product lines have all contributed their share, too. But it's helped us to do things, and you've heard some of these points, like attracting a third of the buyers of iMac as new computer buyers. And in Japan, that's almost half. It's just remarkable every time I hear it and think about it. Almost half of the people walking out with the store with an iMac in Japan have never owned a computer before. And it's helped us to grow our market share. Certainly in the US, you've all seen it and sensed it. Just tremendous growth in our market share. And frankly, it's by making a good consumer product. Before that, Apple simply didn't have state-of-the-art, greatest, groundbreaking consumer products. Well, that is where we're entirely focused for delivering and keeping ahead. It's also helped us in Japan attain just shy of 20% market share. Just phenomenal things going on for Apple in Japan. You've also heard mention earlier of Europe and UK and France. It's going really well, and the iMac, particularly since we've come out with colors, has started to help us grow there very quickly. So you see iMac everywhere. Some people wonder where Bondi Blue came from.
That's the Bondi Blue eyeshadow. Don't miss that.
Yes. But you see it on a lot of great shows. Most of us are busy working at night, so we don't get to catch it. But it's there on 90210 and Spin City, X-Files, a number of great places to see our products cropping up. And this is really due to both the fact that when you have a hot, popular, unique product that looks different, you get great placement, but also a team of people that work on doing this. A very small team that get products out and onto your favorite TV shows and in your favorite movies. So if any of you get a chance this summer to watch The Spy Who Shagged Me, you're going to see some iMac placement in there.
We all question Phil's taste in movies, too. It's okay.
And you've seen this before in Mitch's presentation. John, a native New Yorker.
Gotta go to Bloomies.
It's just phenomenal the way that this is their design, not ours, and yet what's the most prominent thing? I don't think it's the mannequins. See it in catalogs. A great way to make people's products look better is to put an iMac on the desk. So you're seeing in places like Pottery Barn and Crate and Barrel, and we couldn't be happier. And for those of you politically inclined, if you had a chance to go to the Easter egg roll, as you know, it's an annual event at the White House. You saw a tent was set up. Apple worked with the White House staff to actually set up iMacs so all the kids that visited on the Easter egg hunt could come and peruse the web and have fun on iMacs. And we like to joke that there's an interesting White House couple in disguise dressed up as bunnies. You can guess who those two might be. Now, our early design models have shown up in the strangest places. Jonathan Ives' models have even made it to an MIT Jell-O contest, where there were some of the winning entries. And this is something some of you have told us about.
Now, I understand that Hunter Thompson wrote an article here that's fear and loathing in the PC.
Now, this was not part of our placement program. But I hear it's a great story.
So we've had incredible support from all of you, and we really, really appreciate that. Since the introduction of the iMac, there's been over 3,000 products introduced. Ones nearest and dearest to my heart are the USB ones. We have over 175 USB devices shipping right now. There's some FireWire devices shipping. I think it's been a really good partnership, and it's worked out really well. So thank you very much for all the work you've done. I think the other cool thing is on the game front, you know, like 90% of the hottest game developers are doing titles now for the Mac. And that's an enormous change from a year ago.
And if you've had a chance to read, just over a week ago, Walt Mossberg of the Wall Street Journal, a great voice for the consumer in mainstream America, has written an article about USB and FireWire and really praised Apple's ability to get out in front of this, and even said you can't imagine the Windows Intel side being able to do some of the things we've done. So truly a 5-year-old technology invented by Intel has now become popular, and we can all thank Apple, some of the system software we've done, and all of our developers in making USB a reality. And it's going to change the way consumers get to use computers. Now here's one that's just been great. Epson jumped on USB very early, moved their whole product line over to support it, and now with their great new 740i printer has even brought it out in color. In fact,
lots of
5 colors. And this is happening all over the world. One of the favorite places to see this, if you go to Japan, you just see wonderful developer support for iMac and all the Macs. And you in Japan can find just about anything in your iMac color. Your different power cords in iMac colors. You can get translucent USB boxes, hubs in different iMac colors. You can get keyboards of all different shapes and sizes in iMac colors. It's just remarkable. In fact, and it's also become an exciting story in and of itself. Epson made it into Time and Newsweek because of this product that they rolled out. Now, I like to think that that's the kind of stuff we can do together. When Apple creates a great, exciting computer that captures people's interest and developers support it with truly exciting new products, they make it into Time and Newsweek. So if you all work with us, I mean, that's possible for anything.
Okay, so the next product we need to talk about is the Power Mac G3. It's the fastest Mac ever done. Okay, we have always talked about building balanced systems here. All right, so it's not just processor performance, although we have the fastest processor performance. But it's also system buses, memory bus, I/O, disk, and of course 3D graphics. We got the message loud and clear on the 3D graphics, and we are now leading the industry as far as PC 3D graphics goes. Of course, it's incredibly accessible. You just open up the door, you can plug cards in. It's very, very expandable. Because of the built-in USB and FireWire, you can hook up almost 200 devices to this machine. It's got lots of drive bays inside, up to 100 gigabytes of disk storage, today and a gigabyte of memory. So really powerful machine.
Yeah, this is the first personal computer able to deliver 100 gigabytes of storage and a gigabit of Ethernet option as a desktop computer. So we're starting to really get back in front of delivering the most powerful personal computers money can buy.
But we're not just developing the CPU. We're building families of products. So along with this product, we have the Apple Studio displays, the 17-inch and the 21-inch based on Tron technology to get you the kind of quality that people are looking for, and the 15-inch flat panel.
This has been a big change in the last year. When we looked at our product line, we realized that now we can build, out of those 4 products, 3 of them have built-in displays. One of those still yet to come. And only one of them has an optional display, and that's our Pro Desktop, the Power Mac. So now when we design displays, and we design them in a way that no one else does in this industry, we're designing them specifically for the Power Mac customer. That's allowed us to create a line of products with a range of offerings, but just what that Power Mac customer wants. Now, you don't have to take our word on how good this is. We're getting just great reviews of this new Power Mac. Here's one you wouldn't expect to see just beaming and drooling all over the new Power Mac. InfoWorld, an enterprise magazine, and you can read it yourself, but if you've been waiting for the right time to purchase a Power Mac, carpe diem. For those who don't speak Latin, it doesn't mean seize the fish. It has the features and upgradability to keep users happy well into the next millennium. That's just kind of the great reviews we're receiving. I think it was in a local newspaper that said this is the first time he's had techno-lust over a computer. So I think we all want to make products that deliver on techno-lust, and the Power Mac does that in spades.
The third product we'll look at is the PowerBook. Of course, we just introduced a new one yesterday, and it's an outstanding product. More brains, less brawn. So the fastest PowerBook ever, faster than the entry system is faster than the systems we're shipping today, and it's only 5.9 pounds. So we're really focused on weight. Let's show them a little more about that.
Okay. We've always heard that what's Apple going to do in the portable space with weight and size and all that. And what we've been saying for very consistently now is our goal was to get to the most powerful notebook for the real road warrior, and then focus all our energies on making it smaller and lighter and easier to carry around, but not giving up on all that great performance. And so this is the first step of exactly what we've been telling people we would do. So as we look at it,
so on speed, the entry system is 333 megahertz with a half meg backside cache. The high performance one is 400 megahertz with a 1 meg backside cache. So you will get incredible performance out of this machine. Of course, we really focused on weight. Now, if you look at all the other notebooks in the same class, so full function notebooks with 14-inch panels, we're 1 pound to 2 pounds lighter. We decided to put the ThinkPad, which is probably the most successful PC notebook out there, which actually is a 13-inch panel. And we're only 0.2 of a pound heavier than the ThinkPad 600. So really nice job on weight.
Yeah, that's IBM's best-selling ThinkPad of all time, the 600. A lot of people in the PC world love it. And we're able to deliver more performance, more battery life, greater screen size, all around the exact same weight. So just a great success on the PowerBook side.
So let's talk about battery life. Battery life is something we've been spending a lot of energy on, both in the hardware teams and the software teams.
No pun intended.
Absolutely. We get 5 hours on a single battery in the new PowerBook.
Yep.
And so with 2 batteries, of course, you can get up to 10 hours. Actually, we found a bug in the control panel that when they wrote it, they never figured that anyone would actually get to 10 hours. So it just kind of went blank when you plug 2 batteries in. So we actually have to fix that bug at the last minute. But compared to typical notebooks in the industry, which are seeing 2.5 to 3 hours, we are getting 5. We need your help on this, because a lot of the battery life is based on some of the applications. And so we'll actually talk a little bit more further in the presentation about what you can do to help get longer battery life on these products.
So what this represents is we have actually written some Java tests that run what we call city mode, highway mode, and DVD mode. So when we talk about can you play movies, we actually have a test that runs that test. It's a real tough job to sit there and watch movies to see how many you can watch on a PowerBook. But somebody's got to do it. And those Java tests run cross-platform, so we can really measure accurately battery life. So, but when we ran those tests, some of these notebooks actually got worse than this. So what this chart represents is our tests in our stated life based on those tests, and their stated battery. We thought we'll give them the benefit of the doubt and allow them to represent the battery life the way they want. But we found in a number of cases that when we run our tests, they don't quite get to what we thought. Well, who would have thought a PC product that isn't as accurate as represented?
So I think this deserves a demonstration. What do you think? Let's hope the demo gods are with us. I'd like to introduce Greg Joswiak. Jos, take it away.
Thanks, Phil. Thanks, John. So as pleased as we were to get to 5 hours of battery life, which is an amazing accomplishment considering where the competition's at, and also to get down to 5.9 pounds, which, as Steve said yesterday, is kind of a contradiction in in physics. And we also added another feature that I know a lot of you constantly beat us up on, which is built-in dual display, right? And getting that back so you can extend your desktop built in. But the heart of the success that we've had over the last year in PowerBook has been the G3 processor. And we're using copper-based processors now, so we can go up to 400 megahertz. The downside of this, though, is coming up with a good demo. Because G3 is already faster than a Pentium 2, and they can only go up to 366 in a notebook. So where's the drama on that? So what we're going to do today is do some demonstrations of performance against a Pentium 3, 500 megahertz. So you want to help me with that, Phil?
Sure.
He's my boss, but he still has to do the PC. Steve has trained him to do that one once.
It's my job.
Okay, so what I want to show first is we're going to show a Photoshop demo of a real file that was created by one of our customers for Disney for the UK launch of Mulan. And it's a demonstration of actions and filters in Photoshop, and we're going to do, again, the Pentium 3, 500 megahertz, against the PowerBook G3, 400 megahertz. So why don't we give that a try?
So again, it's a desktop, not a notebook, because when we run this against the fastest notebook they have, it's a Pentium 2 366. We totally destroy it. And while that's fun to do, we thought would raise the bar.
It's too boring.
In addition, we're using Photoshop because, as you know, Adobe does a great job trying to tune Photoshop to take advantage of both PowerPC as well as the Pentium. So we know that they've done a great job tuning it, taking advantage of Pentium 2 and Pentium 3, and it really exercises the system. Last, we like to use Photoshop in this demo because we can take the same file, run it on both machines, as well as a scripted set of actions. So this is an animation. It's a full set of actions that an artist would go through to create this document and run those actions in real time on both machines. So you can't get me to do a demo without talking and saying a few things. Okay. Ready? 3, 2, 1, go. PC has started.
Did you start? Okay.
Oh, yeah. So we're laying in some graphics and cropping them and applying some filters.
Another reason this demo is important to us is because when we moved to the G3 processor, which really was the same class of processor we had in our desktops, it enabled a whole new class of applications, your applications, for our customers. And that's why nearly half, well, actually over half of our customers who bought the PowerBook last year was their first notebook. There you go, done on the PowerBook side. Still working. There we go.
There we go.
So about a 20% improvement on performance, even though we have about 20% less megahertz. Do you know where Steve was?
Yeah. Okay, so why don't you tell everyone what we're going to do
Okay,
next?
so what we're going to do now is, again, another creative application that our customers are taking advantage of the PowerBook is Director. And if you remember last year when we first introduced the PowerBook G3, we ran a commercial called Steamroller. It was quite popular. Well, we've taken that commercial and actually made it into a Director file, rendering frame by frame of a Director staged animation. So this is a great way to show, again, what the processor is doing and cranking out frame by frame. And we're going to try, again, the bad boy Pentium 3 500 against our little 5.9-pound PowerBook G3.
And again, Director's a product that's been tuned to take advantage of the fastest Intel processors, take advantage of MMX code, and gets right down there, touches the metal in assembler to be able to absolutely get the maximum performance. It's also great because it shows a little bit more of the bandwidth of the system as you're pushing the graphics subsystem and starting to push across the memory bus a lot of frames. So ready, 3, 2, 1, go.
Oh, I think you got an early start on it. So we still flatten the competition. PowerBook's done.
Okay.
So again, thanks. We should have these available in the next, about May 20th. They should start arriving in stores. So we hope that they help both you and your customers use your applications better. Thank you.
Thanks, Josh.
Thanks, Josh. So last year we demoed a 400 megahertz notebook here as a technology demo. This year we're delivering it. So while the system is designed to have built to order, we've made it very simple with just two standard configs. One at 333 megahertz, one at 400 megahertz. You get 64 meg of DRAM on either model, a 4 gig hard drive on the entry system, a 6 gig hard drive on the high-end system. CD and DVD. Now in the DVD config, we have MPEG decode and hardware on the motherboard, so you don't need to have a PC card anymore, or card bus slot used. We're using the Rage LT Pro with 8 meg of graphics memory, and you get the dual display mirroring features that you've all been asking for. And of course, we're moving to the new IOs, USB, and 10100 base T Ethernet. 56K modem built into both products for the astounding price of
$24.99 and $34.99. And if you compare this against the highest end products, the best products made by IBM and Compaq, many configs you find this up to $1,000 cheaper. So we're trying to be really aggressive on this.
So you get this notebook that's lighter, faster, and 20% thinner than the previous generation. So what's going to happen later this year as far as the... Oh, that's right, we have the new shape, of course. So what's going to happen in 1999? We have this consumer portable we've been talking about.
So I know a lot of people have been cornering us afterwards saying, can we talk a little bit about this? Can we show you it? Can we do anything at all to give you a feel for where we're going? So we thought what might be fun, rather than do what we can't do, is give you a feel for sort of the things we think about when we design this product, the things we want to do, and maybe a few of the things we don't want to do. So we have an example here of a product that we think a lot about when we design a product like this. Hold on. Maybe a few of you recognize it. This is the Apple Portable. You want to help me hold it? So I'll leave it to your imagination when we think about this in terms of things we should do or shouldn't do. But this is sort of the grandfather of all Apple portables. This is the notebooks and products. The Apple Portable, it weighed a svelte 17 pounds when we shipped it. It was a technical marvel. The very first computer ever to ship with an active matrix display, black and white. The very first computer to ship with a built-in pointing device. So again, technically amazing. And then one of my favorite features, you can actually do this two-handed. It had a lead-acid battery. So just amazing achievement. It was started at a very good consumer price point of $64.99 and include the barn-burning 68,000 running at 16 megahertz, included a whopping 1 megabyte of memory and a 40 megabyte hard drive, which was huge at the time, which is why it had to be so big in the back. So again, this may not be exactly what we're doing, but it gives you an idea of the things we're thinking about and looking at as we're working on our next generation consumer portable.
Wait, Phil, you forgot one thing.
What's that, John?
Your 3D goggles.
Yes. Some of you have read on the web that our new products may include 3D goggles in the future. So just to show you that some of the things you read are true, it's working. Everyone is in 3D. So now, this is one of the technologies we're going to have to wait and see what we do. Wait and see. So that's about as much as we can tell you, except to say it will be for consumers and it will be a portable.
So one of the things we've accomplished over the last year is that we have 4 product lines and we've gone to one unified architecture. And that's both on the hardware side and on the software side. On the hardware side, we have a core architecture to the machine. So there's different implementations different features, different technologies, different speeds. But the hearts of the 3 shipping machines today are the same. Right? This allows us to bring product to the market much more rapidly, much more reliable products, and allows the team to really focus on value add and building great designs. On the software side, with the introduction of the new PowerBook G3, we have moved to the New World ROM for all the low-level software. So now all of our machines have the same low-level software architecture and use the same ROMs. Plus, the ROMs aren't in ROM anymore, so it's kind of a misnomer. So the key here is that as we develop each product, we continue to improve the reliability and the stability of the machine. When we come out with a new machine, that same ROM is upgradable on all the machines in the product family and downloadable over the web so that you can install it on your machine. This is a big change from where we were before and really increases our stability and reliability and helps us with time to market. So in talking about architecture, we like to cover 3 specific areas. I'd like to start with PowerPC. Now, working with Phil, it's tough to get a word in edgewise sometimes, so I'm going to bring up some help. I'd like to introduce Glenn Maranker, and Glenn runs our desktop engineering team. He's responsible for all of our desktops, our displays, and our future architectures. So please welcome Glenn.
Okay.
I can talk now.
Good morning, everybody. One of the very important aspects of the product is, of course, performance. And the heart of the performance of Macintosh is the processor memory complex. And some time ago, if you can remember way back to 1994, we enjoyed a dramatic improvement in performance as we started to migrate the platform over to the PowerPC. Now, since then, we've enjoyed a steady, continuous improvement in performance, working with our PowerPC partners, due primarily to 2 things. One is process improvements, and the other is implementation enhancements. Process improvements have allowed us to move processor frequencies from the blistering 75 megahertz of the 601 up to, we've seen 500 megahertz parts. And we've also had a significant number of important implementation enhancements. We've seen things like the tremendous turbo boost we got out of backside caches, improvements in bus interface units, which have improved memory bandwidth. And also not to be overlooked is some time ago, the PowerPC product line had been split into a processor that was focused on delivering performance and another one that was focused on delivering low power. Our partners have succeeded in, with the G3 in driving those 2 properties into a single processor, which allows us to, of course, focus our design efforts, but also means that we can enjoy the same levels of performance in the portable line that we do in the desktop line. Well, it's about time for another big leap in performance. And we're going to get that with the G4 processor with Altivec. I'm going to tell you just a bit about that. The G4 processor is really a tremendous enhancement, evolutionary improvement over or to the PowerPC architecture. It's got a lot of stuff, a lot of function. In fact, we now eclipse in transistor count the Pentium 3. On the other hand, with advanced processing and simplicity of organization, the PowerPC is still substantially smaller than a Pentium, substantially. And we still enjoy power levels which are low enough so that we can incorporate this processor in our portables as well as our desktops. So what else is great about this? Well, what are we doing with all this stuff, all these additional transistors? Well, the next generation PowerPC, the G4, has a dramatically improved memory interface. It does prefetching, streaming, out-of-order references to memory, all this kind of fancy techniques which result in tripling bandwidth to memory, both sustained and peaked. An honest tripling of memory bandwidth. Now, when those things are done, it's typically at the expense of access time to memory, pushing the memory further away from the processor, which doesn't help your performance. But in fact, we'll see faster access, almost 2-to-1 better in our G4, future G4 implementations over our current G3 implementations. There have been a series of very important, no-compromise architectural extensions with the G4. First of all, it is a very aggressive, 4-state, multiprocessor optimized cache architecture, opening up the door for future Macintoshes which will be MP capable. In addition, there's been a collection of enhancements, which I'll speak about in a second, which is specifically designed to make media, DSP-oriented kinds of applications really sing. And these collectively are called Altivec.
Now, when we ship the products at some point in the future, we may choose to rename it because Altivec isn't something that I think my mother would get or understand. So we don't want to promise everyone that that's the name. That's Motorola's name for the technology. But we're still working. If anyone has any great naming ideas for it, you can email me, schiller@apple.com, and we have some time before we have to actually figure out what we're going to call this great stuff. But for now, we continue to use exactly the same words Motorola does and talk to it as Altivec.
So in very brief summary, this brings true vector processing will bring true vector processing to the Mac. It's a 128-bit architectural extension. It includes 32 new registers in support of these extensions, over 160 new instructions for single instruction multiple data processing, and all this has been specifically designed for applications which are extremely processor or memory bandwidth intensive. So the usual collection of multimedia, graphics, 3D, DSP, and technical computations, which tend to be matrix and vector oriented. Now, at a high level, the old G3 architecture can be depicted with this kind of picture. The principal message here is that in the old G3 architecture, there were 3 places that instructions could be executed. They could be executed by a branch unit, by an integer unit, by a floating point unit. And each of these could execute independently of the other. So there was a great deal of concurrency in the opportunity for high performance, because when the instruction stream allowed it, you could have 3 places that you're actually processing data, processing instructions. With the G4, a 4th unit has been added, a vector unit, which contains the registers and the instruction processing, as well as the streaming memory interface in support of that part, this new part of the PowerPC architecture. And consistent with the previous implementations, the vector unit can operate concurrently and independently of the other 3 pieces. And so we now have 4 areas where instruction processing goes on in a PowerPC at the same time. Now, some people have asked what's the distinction between G4 Altivec and the streaming extensions in the Pentium 3. And we have some sessions that go into this in detail later, but again, very briefly, it's a far richer and frankly better organized instruction set. The instruction set and the memory interfaces support true streaming operation, pipelined, with the ability to address and fetch reasonably complicated structures in memory. The instruction handling itself is quite a bit more sophisticated. The units are all independent, and there are no strange gizmos and gadgets, no needs to do mode switching or saving registers in one unit before you can use instructions in another unit, and so forth. And the registers that have been added, there are about 4 times as many as were added in SSE. But with all this stuff, although it may sound complicated, and it was it was certainly a challenge for our PowerPC partners to implement. It maintains the simplicity of RISC. There are no crazy pieces to this. There are additional instructions with tremendous power. They're RISC instructions, register to register, register to memory, no crazy stuff that has to be dealt with. Now, what's all this translate to? I mean, why should we, in the end, we care? Well, at equal clock frequency, if you take a look at some processor-intensive but important and representative computations, you can see that we get everywhere from good to extremely dramatic performance advantages by exploiting the AltaVec instructions, AltaVec extensions. So these are some representative things in several areas: image processing, DSP, and so forth.
Now, we're early in this, obviously, and it's going to take a lot of work together with all of you to maximize the benefits of this, and the benefits are going to be even greater than this. But this is just some early steps, starting to use the product, starting to see what we can do with some very simple, easy work. And over the time, I think you're going to see we're really going to get some extremely great examples of just dramatic performance gains.
So I think with that,
we'd like to invite up a few partners who have been starting to work with AltaVec and figuring out things they can do in their own applications. First and foremost, Chris Cox from Adobe, a computer scientist at Adobe. We'd like to have him come on up. And we have Greg Gilly as well. Honored to have you, sir. Join us. Come on stage.
So I just want to make a couple things clear before we get started. One is no stakes were harmed in the producing of this demo. The other one is that Chris did all the work this time, so no VP hands touch this code. So for you aspiring managers out there, here's an important word: delegate. So what we're going to show you is we've been playing around on Photoshop with the new AltaVec processor, and the results are very encouraging so far. Keep in mind, this is not final hardware, and we're expecting some significant improvements in the final hardware over what we're seeing now. But we want to go ahead and show it to you because we think it's going to be significant. So why don't you guys go ahead?
Sure. Why don't you take us over, Chris?
So what the AltaVec promises is the ability to actually do things that we couldn't do before for various reasons. In a lot of cases, we want to do things interactively, but we can't because you can't maintain the performance levels that you need. So you guys ready?
Yeah. 1 second. So what you have up on the screen here on the left is an early prototype Power Mac with an AltaVec in it. On the right, a Power Mac G3. We've done everything to make these systems exactly equal. So as you can imagine, in the future with our AltaVec G4 machines, there'll be a lot of great enhancements. These machines are architecturally the same, megahertz the same, to make it a truly equal example of just AltaVec benefits. Of course, there'll be many other things when time comes.
All right. Ready? 3, 2, 1, go. Okay, I'm through the first one, and you're...
So you might be wondering why I'm up here crawling since Chris did all the work. Eye candy. What do you think? Anyway, as I was saying before, when we look at performance and we look at the things that we want customers to be able to do, interactivity is very important. And so we spend a lot of energy, as Phil said earlier, optimizing for these products.
So the AltaVec machine is done going through its effects.
So with the AltaVec processor, we can push to the edge, and we can do things that we couldn't do before, and I think that's going to make a significant difference. I think people that are doing computer-intensive interactive things where they're very visual, which is a lot of what we do on the Macintosh, I think they're going to find that they can do a lot more than they could before. And we've been working with the Apple engineers, we've been working with the MetroWorks compiler guys, and there's still some more work that needs to be done on the compiler as well, but we found it significantly easier to write the AltaVec code with the MetroWorks stuff than with doing assembly language. So
yeah, the C API for AltaVec is very well thought out. The intrinsics are very well designed. You don't have to sit there and think about which specific instruction you want for which particular case of variable type, and you let the compiler do half the scheduling for you. It's wonderful. It's so easy to write for.
Okay. So, and we didn't, this isn't rigged, right? So this is just the standard shipping code against the one that we tweaked for the AltiVec. So it gets a little boring at this point.
Yeah.
So, anybody dance?
That's some real tweaking you've done. I like that.
And again, I want to repeat what Greg said earlier. The times that we've got now are on prototype hardware. The final hardware is going to be so much better.
Sorry, don't want to spoil the surprise. So when it comes out next year, you guys are going to be stoked. I know we're certainly going to be, and we know that our customers are going to be, because they're going to be able to get a lot more work done.
Hey, it's done.
productivity.
Yeah. Finally.
Thanks, guys.
Thank you.
Thanks, Greg. Thanks, Chris. So for our next demonstration, our next trick, we have Alex Lally from Macromedia. Alex is on the director team, is a software engineer on the director team, and has started to be able to play with AltiVec to take advantage of its great performance power for multimedia applications. Welcome.
Thanks. Howdy. So actually, before I begin, how many of you out there, have spent late nights optimizing your code, unrolling loops, disassembling, only to get, marginal performance speed-ups? Raise your hands. That's it? Oh, I guess you're not going to care about this then at all. Well, wouldn't it be great if you could get, 50% or greater from unrolling your loops, or, better than at least 10%, or the minimum that you normally see? I'm going to try to show you just that. With this, I've got 2 demos I'm going to run when Phil's ready. Actually, just double check something real quick. Okay, ready?
Sure. 3, 2, 1. Don't have to count down on this one.
No. So this movie here is a director shockwave movie. It's just a projector. We'll wait for this one to come up. Actually, I'll start. So it takes a little while for the frame counter to settle. As you can see, the AltiVec machine is already starting to pick up the speed. So this is only probably about 40% of our lit pipeline has been optimized. I haven't had much time to do much of this work. I haven't run the profiler. I haven't done any prefetching or anything like that. So here we're seeing about 100 frames compared to, I'd say, about, 80 frames over there. So it's about a 30% faster so far. So I guess we didn't quite hit 50%, but in this next demo we should be able to. So now, this demo, it's a lot more AltiVec code. And as you can see, here we're just basically beating the pants off of the G3.
So what is it actually that you're using in AltiVec that's driving this demo and taking advantage of an AltiVec?
Yeah, one of the reasons that this runs so fast is because these, the source images are 16 bits and the screen is also at 16 bits. And to do this sort of blending, we need to promote everything to 32-bit pixels and do the math and then go back to 16-bit. One of the really nice parts about the AltiVec technology is that there's an instruction that takes 8 32-bit pixels and packs them into 16-bit pixels, and that's one instruction that does that. So obviously that's why this is running so fast. And I was telling the MMX engineer who wrote, this portion of the code that, and he basically said that's cheating. so I guess you're not going to find that instruction on Pentium 3.
So I guess MMX engineers think good instructions are cheating.
Guess because they don't have them.
Yeah.
So let's see how fast this really was real quick before I go away. Let's see, so what were we getting over there? 31, and what were we seeing over there?
Anybody? About 20?
20?
36.
26?
36.
Oh, 36, and what was the other machine?
20.
20. So that's 80% faster right off the bat, and I barely did. I've optimized maybe 10 routines, and I haven't even profiled the code yet. So it's very easy to get very fast code. So
Great.
Thanks.
Thank you very much. Well, we have one more demonstration for you. I'd like to invite up Terry Folcono, who's a lead engineer at Research Systems and has some very exciting software to show us, really tuned at the scientific and engineering markets. So, Terry?
Thank you, Phil.
Come on down. Good to see you.
Good to see you. Hi. Like Phil said, I work for Research Systems. We have an interpreted language targeted at scientific visualization and analysis. And basically, I got an AltiVec unit about 9 days ago, started playing with it. One of the fundamental types in IDL is the array, and I figured that AltiVec might be a good fit for that. So we started speeding up the basic array operations and a couple of filters about on Wednesday. In about 3 days, had put together a little demo that we're going to show you.
Okay.
Basically, what this is going to do, some of our major customers obviously are NASA, government research labs, universities. So we have some pictures from the Hubble Space Telescope. And let me just run IDL here. Oh. And basically what this is going to do is it's going to go through a series of 8 images. It's going to do quite a bit of processing in between frames, doing about 200 million. Every time you see the image change. So it's doing about 1.6 billion byte operations for the whole thing. It's also going to, just so visually you guys can see what's going on, it's cycling through colors, it's doing filters. So let's see.
So there was a time when this was a supercomputer task. Go through 1.6 billion operations on a series of space photographs to optically enhance them.
Yes.
So on the left screen, an AltiVec machine, on the right, a G3. If you'd like to count us down, and we'll click go.
All right, Phil. 3, 2, 1, go. So, as you can see, the AltiVec is obviously going much faster. Anybody doing real work would probably want to take a little bit more time to look at the images to try and extract some data. But, if you're doing batch processing or something, obviously AltiVec is phenomenal. Now, like I said, I've basically just scratched the surface. It's about 3 days' work. The AltiVec is done. IDL has a lot of areas where we can use AltiVec. And I think for our customers, it's going to be quite compelling. The Macintosh, the way it is now, basically, the combination of, we also have OpenGL, so the combination of the Rage 128s and the high-performance video cards, as well as the raw number crunching speeds. We're looking good.
Just to end, could you share the comment you made for me about once you've seen this at IDL, what the sort of feeling around the company's been with seeing this machine in action?
Well, they were quite amazed. When I originally started and did the basic ops, basically I got an initial 5 times speed up. I ran around saying that I can do 1 billion operations in under 4 seconds, and it's about 3.8. And the PC engineers and the Unix engineers, we're extremely cross-platform, so we have pretty much everything. Said, no way. Came around and took a look at it, and they've been floored, basically. And at one point, we were wondering whether we should put AltiVec support in the product or not, manage hedging their bets. Now that they've seen it, the decision is getting a lot easier.
Great. So Power Mac with AltiVec flooring Windows and Unix engineers everywhere. So
yes, absolutely.
Cool.
Absolutely.
Well, thank you very much.
Fastest thing we've got. Thank you.
So lest you want to go out and sort of throw away your great new G3s, which are all brand new, we should talk a little bit briefly about timing here. Power Macs with AltiVec and G4, we certainly will deliver before the next time we meet again, is our commitment. You'll see these shipping in products before the next developer conference. Certainly we'd like to have them out there in the first half of 2000. We're working really, really hard to get these done and out in the next generation of the Power Mac line. So what are we doing? A few of the things just at a high level here. We're certainly doing work with our own OSs, with Mac OS 8 and Mac OS 10 to take advantage, to make it transparent to applications that can automatically get a benefit of being on top of a processor with AltiVec on it. We're going to do things within the core graphics system within QuickDraw, QuickTime, and OpenGL to take advantage of AltiVec code ourselves. In addition, there'll be core libraries that developers can use to get very fast benefits from the AltiVec processors. And so you can see a lot of things coming your way that you'll get instant speed ups, in addition to the great work you see up here from people who are able to get in there, take specific advantage of AltiVec.
There's some great libraries coming, Phil. It's very, very impressive.
And for all of you who use Code Warrior out there, the support for AltiVec within Code Warrior, we have an AltiVec SDK available now. You can get it and get information on it up at our website there. You see the address listed up there. There is an AltiVec page. We have a C-based programming model, and there are kitchens and technical support available. So there's no reason to sit around and wonder if it might benefit you. It's time to get started now so your apps can be ready and available for when AltiVec is shipping in a Power Mac.
So as you can see, that the opportunities for just a leap in performance, I mean, above and beyond what we're going to get from all the other platform improvements that we're doing from the increasing megahertz of the processors, is about to be exploitable through use of AltiVec in audio, video application, decoding, encoding, all kinds of image processing applications, scientific calculations that both do a lot of arithmetic and move large blocks of data, encryption, and any number of DSP-like algorithms such as speech processing, handwriting analysis, and so forth. So if you have something that looks or smells like any of those things, you should be thinking you shouldn't be thinking, you should be doing something with AltiVec. So to help, besides all the other things that Phil mentioned, at least during WWDC, we have a variety of sessions over the balance of the week that go into AltiVec in greater detail, that give guidelines and the theory and help in how to organize code in order to exploit AltiVec, as well as a feedback session. We certainly want to hear from you folks about this.
Great. Well, thank you very much, Glenn.
Thank you, Glenn. So, you know, when we do come out with the G4 machines, you will develop your apps for them. It's like giving a supercomputer to your application. It's great. Next thing we like to do is talk about some of our subsystems we're working on. And I'd like to bring up Greg Paley. Greg is in charge of our CPU software, which is our machine-dependent software, drivers, firmware, all that low-level stuff below the operating system. Welcome, Greg.
Good morning. We've actually made quite a few changes under the hood of these pretty systems over the last year, and we're continuing to do so. And so I want to talk to you about some of what we've done and what we are doing that with particular relevance to what we think is important to you as developers of hardware and software. So I'm going to talk about a little bit about the system ROM. I'm going to talk about memory, something about what we're doing in terms of graphics strategy, audio, some new things we have coming up in power management, some tips for PCI developers, our story on mass storage, and then we'll go on a little bit more about our connectivity strategy, which is embodied by the dual mantra that we keep chanting right now, USB, FireWire, USB, FireWire. I'm not going to tell you what I'm channeling. On the system ROMs, as John mentioned before, we have split these into two pieces now. We have the macOS Toolbox ROM, which is now a disk file, is actually executed out of RAM, and which is absolutely the same for all of our systems now that we have the new PowerBook G3. So every single consumer desktop, PowerBook, and mysterious fourth quadrant there are going to have exactly the same macOS Toolbox ROM running in it. The boot ROM, which has the open firmware code and has the other hardware-specific initialization things, is a flashable part. And because of that, that is now very easily updatable. We have and we can post updates on the web, same with the macOS Toolbox ROM. The really important thing about this is that with this greater simplicity and the leverage that we get, not only can we come out with new systems much faster and much more easily than we have before, but both from our standpoint and from yours, it really lets us concentrate our resources and our testing on really making these things absolutely bulletproof and making sure that they're really, really reliable, and lets us spend our time adding value rather than continually reinventing wheels. In memory, what this shows primarily is the steepness of the curve of what we're doing in terms of throughput and access times. You can see that we've doubled from the original G3 in just a little over a year to the current systems, and that arrow there basically shows the commitment of where we're continually going to be pushing that envelope further, because we understand that in addition to microprocessors, memory access is really at the heart and soul of performance of a system. In terms of memory capacity, we have a similar story here. We are now getting to the point of allowing over a gig of memory, and both in hardware and software, since the OS has to support it, we're continually also pushing upward with also the same steepness of curve. Graphics. A year ago, when we introduced the iMac, we were asking you for feedback, and you gave us some heat about the 3D graphics performance that we had. And personally, I'm really, really glad that you did, because you woke us up. And I think it's really, really exciting to be again in a position where we can claim leadership on the graphics. The first step of that, of course, was when we rolled the iMac as quickly as we possibly could to the Rage Pro. But I think the statement that shows where we are and where we're going was the introduction of the PowerMac G3 with the Rage 128 that really put us at the top of the curve and actually had us the very first to lead an industry standard, an industry-leading high-performance graphics chip. We're going to keep doing the same thing. We like the exhilaration of being there, and so as you see new products come out over the next year, you're going to be able to compare competitively with anything else in those price points. We are not going to be outdone in terms of graphics performance. Now, in addition to the hardware, you asked for a powerful 3D API, and we have decided, based largely on your feedback, that OpenGL is the way to go. So, having announced OpenGL as a strategy just a couple of months ago, or a few months ago at Macworld, we now have version 1.0 that's downloadable from an Apple site, and that version does use the full 128 acceleration capability, and we're going to keep that moving forward. There will also be a developer session on OpenGL, and we really want your feedback. In fact, I'd say with all of these things, we really, really ask for your feedback. One, to affirm what we're doing if you think it's the right thing, because we're continually reviewing decisions, and we really, really believe that the key to our success is being in touch with you and knowing where you're going and what your plans are so that we can make the right decisions. And then, of course, where you think we're wrong, tell us. Audio. Audio has been a hobby and a love of mine since I was a teenager, audio and music. And so I'm really, really pleased that we at Apple now have decided that we've perhaps let that leadership lapse in the 90s, and we're going to really make some major changes in audio going forward. Now, we're migrating to digital on the computer. This is nothing against analog audio. I mean, there's great sounding analog audio, but on a computer, digital is really what makes sense. So as with the general theme of this conference, we're not announcing any specific support of new things or specific things that we're taking out of our systems, but this really is a heads up that the analog inputs and outputs, their days are numbered on our system. So we're really recommending that you migrate yourselves to digital. Of course, for those of you who can't live without a way to get an analog stream in or out, there is, again, going to be that answer in devices of USB, FireWire. We are going to support and put a great deal of effort continuing into supporting FireWire and USB peripheral devices. And we're doing some things in software for audio, too, that I think are really exciting. We have a new 3D positional sound API in Game Sprocket that is going to completely replace the current 3D rendering engine that we have. And there is going to be a Game Sprocket session on this, and we'll have Ted Tanner, who is one of the best audio architects in the industry, and a great guy speaking at that. And again, as with everything else, he's not only there to tell you what we're planning, he's there to listen to you and hear what you want to do, because we really want to work with you and make your apps, particularly your games, provide a great immersive audio experience to add to the graphics that we're putting into these systems. We're going to be introducing a kind of a multi-channel virtual surround sound so that you get the full 3D virtual image, even out of 2 speakers. Wonderful for DVD playback and other, again, immersive experiences from audio. And we're going to be introducing bass enhancement to give you a much fuller, richer sense of sound, even out of the built-in speakers that are in the computer. Power management has a new architecture from us now, and a really important point for you developers is that this is no longer just a PowerBook phenomenon. We are going to be bringing this architecture across all of the platforms. It's really important now to know that if you think you have something that's a desktop application only, it's also going to have to be power management savvy. We're going to add some sophisticated features to the power management, such as the ability to wake on LAN activity, and it's going to be a more robust and a more thorough power management than we've had so far, with the ability to selectively turn off the various subsystems like the PCI, USB, and FireWire. But again, that's why it's so important that your applications and your hardware be power management savvy in this regard. Now, 8.6 has brought in some of the enhancements we're doing. It's also brought in some additional battery life, but that's just the beginning. Both in hardware and software, we're going to forge some really new ground in terms of power management. So please, please come to the Power Manager Guidelines session to find out what the guidelines are for being able to make sure your apps stay stable and really make good advantage of this technology. PCI, I want to talk to PCI developers for a minute. You are getting very, very sleepy. You will attend the power management session. You will provide 3.0 compliant firmware so your device shows up at boot time. And you will never, never, never assume or use fixed slot addresses or numbers. You can wake up now. We have a new time manager, and a developer or beta version of this has just been posted. And some of the major features of this time manager are, now we've gone fully PowerPC native. Yep. We no longer rely on the VIA or any legacy hardware. The API calls run 200 times as fast as they do, and because we don't rely on the VIA or any hardware, using the time manager, making calls to it are no longer going to have bad side effects on your PCI bus performance. So we think this is going to be a really good thing, particularly for AV solutions that need fine granularity, fast access, and where you have to make sure that certainly nothing you do is going to have a negative impact on the overall system throughput. In terms of our mass storage story, currently on the motherboards of our systems, we're supporting the ATA Ultra DMA 33. And we found that with this strategy, we've really been able to get marvelous performance for the price that really seems to satisfy the mainstream requirements. And so this is going to be our strategy going forward for what we put on the motherboard. The only difference is going to be that over the next year, we're going to migrate onto the 66. For those of you who really, really need the absolute and high end, and particularly who need to have these very, very large, complex drive arrays, we will continue to support the SCSI Ultra 2 LVD, but that will be done via PCI card. Right now, we're staying consistent on the story as far as what we put into the box. We're not putting any floppy drives, again, USB. And as far as DVD is concerned, right now DVD is an option on our systems. As we go forward, it's going to increasingly become a standard component of the system. And then, as we're going to be following right with the trends on DVD RAM as well. We're also going to be working very, very hard with you to make sure we have the absolute leading edge on support for external USB and FireWire devices for mass storage.
Let me jump in there with the DVD RAM one. For those who haven't taken a look at that, it's a device we're just starting to make available with our PowerMac Pro line. And we think it's a great option in the future as we look more and more. So Apple is not saying removable media goes away. We support it tremendously. But there have been so many variations and so many options that we want to support all those choices for customers with USB. For example, in the US, zip is very popular. In Japan, MO is much more popular. So you have to look at it by country and customer. And DVD RAM is great because it allows us to offer customers one drive that can read CDs, read DVDs, and write very large multiple gigabyte disks with DVD read-write capability. So it's one of the great things we see coming forward with our product lines.
Some of the sessions, again, that we would really like to see you at this week, The Power Manager 2.0, really need to emphasize that because it's going to be critical as we roll out our new systems. And then we invite you to the game Pocket. And we will have a session on OpenGL, and again, not only to talk to you, but also to hear from you so that we can make sure that we are making absolutely the right decisions in hardware and software to be able to make your apps run best on the Mac platform.
So the third thing we're going to talk about in architecture is USB and FireWire. We keep talking about USB and FireWire. It's kind of important. So let me just do a quick review on what's the story behind USB and FireWire. Well, everyone by now, since they've heard it so many times, should know they're both serial interfaces. Right now we're using them for external interfaces to the system. That may not be that way long term. The USB is really for entering consumer peripherals, human interface devices, joysticks, game pads, removable mass storage devices, inkjet printers, those types of devices. And FireWire is really for the multimedia and pro peripherals and some of the consumer electronics devices. Digital video, obviously, higher end printers, faster mass storage devices. So those are the class of devices that run on USB and FireWire. USB is up to 12 megabits per second, and FireWire is up to 400 megabits per second. We get 127 devices on USB and 63 on FireWire. Now, truth in advertising, we've actually only tried up to 115, or 118, which I believe is the world record anyway. So, but we're working on hitting it all the way to 127. We get hot plug and unplug. Can you imagine what the mess of wires it is like with 127 USB devices all in one room? It's quite a challenge. These are all hot plug and unplug. So no switches, no weird cables, no terminators. You just plug the device in, it appears on your system. You unplug it, it goes away from your system. You don't have to worry about power cycling your machine or doing anything else. We also provide power on the bus. So that means that for the lower powered devices, you don't need to have a brick or an external power supply. And we'll see that with some of the demos we're going to do in a little while. This replaces our legacy interfaces, old stuff that's been around for a long time. It's time for it to go away. Serial, ADB, SCSI, analog AV. Right? Those interfaces are gone. We can simplify and optimize our systems.
So just looking at the math there, with just having a USB and a FireWire port, we have 190 devices that can be added to our personal computer. But now you don't have to open the box, you don't have to restart it, you don't have to try to figure out arcane stuff. It all gets added on the outside while you're running. And the analogy we like to give consumers, it's sort of like your home stereo. Can you imagine the next time you wanted to add a DVD player to your TV? You'd just turn off your TV, open it up, of course discharge it because it's still on, reboot the software, reload some drivers, hook it back up, add a card just to be able to watch a DVD. That's not the consumer experience. And now with USB and FireWire, you can have more performance than we ever had before, more devices than you could ever come close to before, and it's just as easy as plugging in a DVD player to your TV.
So over the last year, we've aggressively moved USB across our product line. So the 3 shipping products today in the quadrants are all USB enabled. I will leave it to your imagination what's going to be in the 4th quadrant.
On the software side, with macOS 8.6, we introduced a 1.2 version of our USB software. Important here is support for isochronous services and interrupt-out data transfers. This is going to be particularly critical for being able to bring audio devices, speakers, etc., to there. Also, in the 9 months since we first introduced USB last year, we've learned about how many really complex chains of devices we can expect to have to support. So we've done a lot of work to really make that stable and to be able to try to actually predict any kind of potential issues, conflicts, etc., before you're going to actually face them. So we're putting a tremendous amount of effort into making that absolutely, again, as bulletproof as possible. Now we do support PostScript printers. Lexmark, for example, has a PostScript printer. It runs really beautifully with the USB services that we have in macOS 8.6. And now we've just posted a mass storage class driver which works across the whole series. I mean, the whole point of the class drivers that we produce is when you want to be absolutely sure that you have support for a wide range of a device category. So this just gives you an idea of how far we've come so far, again, and really just in 9 months. I mean, we started off with the basics in terms of the mice and keyboard and being able to just support the hubs. Then we added in support for multiple buses, other PCI cards, and now with this latest release we have isochronous services, the ability to handle sleep and wake, interrupt out, multiple drivers per file, and the PostScript printers, as well as input sprockets, the mass storage class device driver. And coming really soon, we're going to have the ability to do a full suspend and resume, remote wake up, and this is very, very important, particularly for developers here. We're going to support net download of drivers, and in fact, it's going to be crucial that we be in contact with you to be able to make your drivers available. The idea being that when a device plugs in, that if the driver is not there on the hard drive, that it's going to be able to just go right out to the network and find over the internet the right place, bring the driver down, and automatically install it. For the previous generation of PowerBooks, we're going to support the ability to have the card bus cards. And of course, we don't need this for the PowerBook G3 since that includes internal USB. And we're going to be providing more class drivers. We'll provide a COM class driver, an audio class driver, a HID class, and we're getting ready to support the force feedback devices.
So with that, I'd like to invite up David Moody, our Senior Director for Desktop Product Marketing. Welcome, David.
Welcome. What I want to do is show you a couple of the things that Greg was talking about on the roadmap. Of course, the Macintosh is all about simplicity and a transparent user experience. And that's really the reason that we adopted USB and adopted it as aggressively as we did. But there are some things that we can do to improve the experience even further for both you as developers and for our customers. So I want to show you some of these things. Okay, the first thing that I want to do is talk to you a little bit more about the net downloading that Greg talked about. I like to call this drivers on demand. You know, as a customer and you're purchasing a new unit, something like that, you may, especially a consumer, you know, who's buying their first unit ever, they may not understand the things that they need to do to make a third-party device work with their system. Well, today the process is not as good as it could be. You know, when you plug in a device and the driver's not there, what happens is you get a system alert that says, hey, I don't really know what to do here. You might want to contact your vendor or look for your CD or something, but I really don't know what to do. So what we're trying to do is make that process a little bit smarter. Let me give you an example here. So I have a zip drive right here, an iOmega zip drive that I want to plug in. Now, I've preloaded the system so that I don't have any device drivers available, and I'm just going to plug this in. Again, before you would have gotten a message saying, I don't know what to do. Now you'll get a message that says, hey, I can't find it on this computer, but I can go out to the internet and search for it. Do you want me to do that? So I'll say, sure. Okay, Greg, you may want to start your chant again here, just to make sure.
So this is live on the internet right now, going to an Apple server.
Okay, so what happened is we went out to an Apple server and basically constructed a query, went out to the server, and the server came back with a list of devices that will work with this particular USB device. And so I'm going just to select the default there, and the download will start. It'll take a few seconds here. Depending on how many of those 25 megabyte QuickTime Star Wars trailers are being downloaded at this particular moment. So it'll come down.
Well, David, you didn't even give me a chance to warm up on that last one.
Sorry.
Be patient.
It really will work.
It's young code.
It always has before.
Phil, did you pay the phone bill?
What is happening behind the scenes is that once we specified the file that we wanted to get, a query was sent up to the server again, and it talked to another server, or at least hopefully it's talking to that other server, and the server will transfer the file. Well, maybe not in this particular case.
Oh, there it goes.
I almost gave up too soon.
There it is.
Had me worried there.
It's a little difficult to control the speed of the internet, unfortunately.
Yes, it is. Well, especially with pre-alpha code here. The other thing that I wanted to talk a little bit more about was the concept of class drivers. Greg mentioned that we just posted a mass storage class driver, and that is actually what just got downloaded, and the reason that you see the zip drive pop up like that. We're working on a number of other class drivers, and the whole idea here is to make the experience easy, again, both for the user and for you as a USB device developer. What we do is take on the work of creating a driver that meets the USB class driver specification, and you as a developer don't have to unless you want to add specific functionality beyond that specification. So you don't have to worry about writing, testing, maintaining, updating code on a regular basis, and hopefully it allows you to work more on creating great hardware for the product. So let me show you real quickly just how it works in this particular case. Now, we've already, we downloaded the driver, the zip drive popped up. What I want to do now is add a couple more devices. I've got a LaCie hard drive and an iMation SuperDisk here, and I'm just going to plug them in, just like I did the zip drive. But now the difference will be that the driver is already there, and Super Drive will come up in just a second, with one driver. With one driver, we were able to make all those devices work, and that's the concept behind class drivers. Again, make it simple for the user so that there's fewer vendor calls, make it simple for the developer.
Thanks, David.
Some of the sessions on USB that we want to invite you to this week is a general introduction, and as we often do, we'll have an intro session, we'll have a more in-depth session, and again, I'll keep emphasizing really, really important to us, a feedback forum so that we can have a chance to hear from you.
So I think that USB is a real success story from us working together. I mean, together over the last year, we've made it really work, and it's really gratifying to see all of this happening now, and all of the products that are out there. So what we have to work on together next is FireWire. All right? Last year, FireWire was optional on our desktops. As of last Macworld, we made FireWire standard across the PowerMac G3, 400 megabit FireWire. And with the new PowerBook, we have an optional PC card, goes in the card bus slot, that also gives you 400 megabit FireWire. So all of our Pro products have FireWire capability. We've been putting an enormous amount of effort into the software, and we want to work together with you to make the same kind of success out of FireWire that we did out of USB. So Greg, can you fill us in on some of the software?
Well, again, with macOS 8.6, we have a new version of the FireWire support services, FireWire 2.0. The big feature here, two things. One, the SBP2 protocol is supported for the ability to plug in FireWire hard drives. It also now supports FireWire printers. And we have CMP, which is going to allow you to put multiple cameras on to really make a Mac a wonderful content and video development and creation station. And then we have, coming up soon, a version 2.1, and among the various things that are going into 2.1 are two features which, in fact, we're already going to demo today. One is the ability to capture directly from a DV camera to FireWire drives, and the other one is card bus support, as John mentioned, so that we have a way to bring the FireWire seamlessly across onto our PowerBook platforms. As with the USB, just again to show you the evolution of where we've gone with FireWire. Now, this has been a longer time than with USB. We've had several years, but it started off with basically FireWire being just a DV phenomenon, and of course we're still going to emphasize wanting to have the absolute best DV performance that can possibly be gotten. But now that we've added the SBP2, we've added the hard drives, we've had the printers, more support for multiple cameras, and we're going to be going on with the high-end AV-DV converters, card bus support, as I mentioned, the ability to capture to a hard drive, scanners, the CDRW, read-write standard, FireWire DVD-ROM drives, and additional hubs. And then the next thing that we're going to be coming out with quite soon is having support for the FireWire hard drives. Now people will want to boot from them. So we're going to be coming up with the ability to boot from FireWire hard drives. And we also believe very much in MLAN as a standard for being able to support MIDI devices and other audio devices. This is something that Yamaha in particular has been championing. We think it's a great standard. We're going to be putting a lot of effort into working with MLAN during the course of the next year. As I mentioned before, since we're power managing all of our systems, we're going to make our FireWire subsystems and the software power management savvy. And we're going to now start to support the new high-end solution of DV cameras, which is the DVC Pro 50, as well as other digital audio inputs and outputs in consumer electronics. The DV cameras I'd heard about, but I was stunned myself when I saw the quality that can be gotten out of these, even in a very, very low price, accessible to the consumer. You can do things with these that several years ago would have required easily over $100,000 worth of studio equipment. So of course, we want to be able to stay right on top of being able to support DV cameras and be able to manipulate that data. In addition to the things coming in top quality, the wonderful thing about them is that you have no degradation in the quality as you make multiple copies. They're pixel perfect generations. So today we support the consumer standard of the 25 megabit streaming DV cameras with their 411 sampling rate, but we are getting ready now to support the new really, really high end for broadcast and studio quality production, which is the DVC Pro 50 with the 50 megabit stream and the 422 sampling.
So this is worth taking just a second. One of the largest strategic directions for Apple over the next year ahead will be with video. You've seen us do a tremendous amount with new versions of QuickTime, some Final Cut software, and the things we're doing, bringing out FireWire filing across our product lines. And when you put this all together, the QuickTime support for DV, the new DV cameras, there's over 4 million DV cameras out there in consumers' hands now and growing very rapidly. And with the ability to now, with editing products like Final Cut Pro, like Adobe Premiere, and all the great software out there to easily edit this stuff, the old way you did video is gone. Customers used to have to take a camera, buy an analog board, and before they captured their first frame of video, they had to figure out a trade-off between frame size, color depth, frames per second, and the cost of the board they were at. It was very complex, confusing, and it degraded the quality of video before you got your first frame on your computer. Now that's all gone. You can buy consumer digital cameras that are just remarkable quality. You can plug them into your computer with FireWire. You can support the DV format with QuickTime. You can edit it in some of the easiest to use video editing software that's ever appeared. And so now we have the first true mainstream digital end-to-end video products for consumers, for higher education, for small business. This is just a huge change for us, and it's something Apple's investing a lot in and working with a lot of you out there to drive this market forward in the next year. This is very, very critical to expanding new uses of personal computers. So with that,
time for
David,
a demo.
You want to come back? David,
Okay.
welcome.
What I have, guys, a shipping VST FireWire hard drive that you can fit into your shirt pocket practically. How many of you were at Eric Anderson's FireWire overview session last year? A handful of you. Remember the demo that happened there? Great demo. At the time, we used a PC card or PCI card that we had just started shipping. We were just getting it out of the gate. And the drive itself, the hard drive that Eric used in his demos, was actually homemade. It had a little aluminum metal case, and he had built it in his kitchen the weekend before. Well, I'm happy to say that we've come a long way here with new FireWire hard drives and other cool devices like this. And I just want to show you what you can do with it. So, what I'm going to do is something that in the world of SCSI would have been a fairly complicated and tedious process. So let me just go ahead and do it. I have a cable. Notice no power needed. I'm just going to take this and plug it in. What happens is the FireWire bus resets, and voila! You see the files on the drive. So let me just go ahead and kick things off. We'll move it here so you can see we've actually got a file, and we're going to exercise it here. In the world of SCSI, this would have been a very complicated process. You know, when you talk about adding a SCSI drive, the first thing you have to do is a little research on firmware and drivers and make sure that everything matches up. get those things loaded, shut down your system, crawl under your desk, examine SCSI IDs, make sure that you don't have any conflicts, check terminators, all kinds of things like that. And then finally, as you start up the system and it starts booting and the icons march across the screen, you pray. You pray like crazy that the gods of SCSI will be kind to you one more time. With FireWire, it's different. It's a very, very simple process. And so this is one example, but of course FireWire supports multiple devices. So why don't we extend the example a little bit? I've got 4 other hard drives here that are connected via a hub, and I'm just going to take a cable and plug those in. You see a little stop, and they're all there. While the file was running, the drives came up and the file just, or the movie just resumed play. Now, I'm going to do one more thing that in SCSI is a really, really bad thing. You would probably lose the contents of your drive. But in FireWire, we have a way to manage it. So I'm actually, while the QuickTime movie is playing off of this hard drive, going to disconnect it from the FireWire bus. You see that the image stops. You get a little alert that says, hey, you're not supposed to do this. Would you plug this thing back in? And I will do that. Once again, it resets the bus, and the file just keeps going. Pretty neat stuff, pretty simple stuff. Okay, let me switch over to another kind of use. What I'm going to do is actually do a capture of a DV image from a DV camera directly onto the FireWire hard drive. And so let me switch over. Hey, Phil, could you, or John, either one of you?
I'll go.
I need a subject here. Okay.
Like last night. I was taking lessons last night.
Wait, you can't go yet.
Can't go yet? All right.
Okay, do your Gregory Hines imitation. Excellent. Okay, we just captured that image. There you see it. Hey, pretty good dancer there.
There you go.
I'm going to go ahead and quit out of Final Cut and save this file. As you see, it goes directly to the FireWire hard drive. There's a new file there. Again, the scratch image that was being captured in real time, that was on that drive as well. So again, the nice thing about FireWire is not only does it give you great performance and it gives you the flexibility that you've just seen, but it also gives you the opportunity to actually change the workflow and the process that video editors and that pre-press professionals use, because it's just so simple to plug in, it's so simple to move around. So what I'm going to do is take this drive and actually unplug it from this computer and walk it down to the PowerBook. Okay. Now we have a newer FireWire to Go card installed in this, be available sometime next month. And in a second here, you should see the image pop up. There it is. And I'll just swing into Final Cut real fast here. Move that movie over. And there you go. It's that easy to change workflows.
Thanks, David. So, I mean, that shows a couple things that are just great. Number one, obviously, huge benefits to all of us who use our Macs daily in our lives, as well as our customers, as well as how quickly we can move from an inspiration. Last year, a demo of a sheet metal box that was just with, prototype code, to actually this year shipping FireWire on our computers, shipping new versions of FireWire software, shipping FireWire cards for our PowerBooks, and having a third-party deliver FireWire hard drives. And truly, we went from an idea to a business and a market for people in 1 year. I also want to point out the great support of the guys at VST. These are the kind of opportunities we love to see, where Apple is able to create some innovation, create some technology, and create a new market that a company can come into and very quickly establish a new position and really start a new business. And that's what we used to do so many times in the past, and so many great developers built wonderful business around new emerging opportunities because they moved fast. And these guys at VST have been wonderful, and I for one, like to thank them for jumping on this.
And again, we have sessions for you. We have a FireWire overview, which is for those of you who are first getting into this and covers the basics. We have a more in-depth on how to code and how to really exploit the technology. And again, as always, very, very important, a feedback form.
Thank you, Greg.
Thanks, Rick.
So the other area we've made incredible advances in the last year is in design. We saw it a year ago with the iMac. You've seen it with the PowerMac G3 and the family around there. You know, the PowerBooks. We are breaking ground on material science, driving use of new materials, on things like soft feel paint, on the way the whole product looks. It looks cool, looks beautiful. Some real advances there. But it's more than just design. It's form and function, too. You know, I was sitting around this weekend reading my Vogue magazine to see what was in style. And it turns out the iMac is stylish. So everyone has to have one. Right? But it's more than that. It's designing in form and function so that the ID is worked around the actual function of the machine. So things like the handles on the iMac, the handles and the door on the PowerMac. Right? The whole PC industry is going right now, I could have had a door. So the question is this a sustainable advantage? And the answer is, you bet it is. We have a world-class industrial design team led by Johnny Ives, who would normally be here actually doing this portion of the presentation, but he's busy working on really cool stuff for the future. It really does, it looks great. But it's more than just a design team. You can't just go write a check and go, okay, go design me some great products. It's a real cross-functional effort between the industrial design team, the mechanical engineering product design teams, the electrical teams, all working together to make this happen. Now, the PC industry is catching on. Right? I mean, we've seen some concept computers that look like fish, bunnies, sticks. I mean, there's all kinds of conversations.
Don't laugh, it's true. It's sad but true.
Sad but true. So we can't rest on our laurels. We got to keep moving. We got to keep moving fast, and that's what we're doing.
Now, it's been just over 1 year since we introduced the iMac, so the PC world has had a year to try to look at what we're doing. They've had a year to see the success we've had, and everyone from Dr. Grove to Michael Dell has recognized that the iMac has set a new direction that a lot of people will need to follow. And so we've been scouring the world, truthfully, to figure out who's going to be first, who's going to start to copy us, and how will they be able to do some of the incredible things we do without the tools and the skills and the people and the process to deliver the kind of products we deliver, like the iMac, like the PowerMac G3. And we actually have found the first company, they've been announced, to deliver on some of the ideas we've done with iMac. And they've put out a press release in the last couple of weeks and have been written about everywhere. So I thought it's only fair to show you where the PC world is going. So this is a product by a company called ATOP in Korea. They've announced a color translucent designs that any PC company can OEM. So you might see these everywhere. What's really great is not only do they recognize our leadership in design and translucent and materials, but they've also copied us in color. You can see some of the great colors they're offering there.
Like blackish green. I'm looking forward to see the translucent black enclosure.
Yes. So it's fun to make fun of the competition. It's great to see that once again, that if Apple's doing the right things, they're going to follow us and try to do some of the same things. And it's great to see, even after a year, that they haven't been able to easily follow us. But with all that joking, as John said, we're not sitting back. We're not waiting for someone to copy Apple. Everything we're doing is just going to be remarkable and exciting in the next year. Now, in the past, Apple would trot out a bunch of designs to show you, because in reality, years ago, most of those would never make it into a shipping product. And it was a very sad thing to walk through this great industrial design lab and see that it was just a lab and that many of the things never saw the light of day. And customers were cheated from the great things that organization can do. But together with hardware, engineering, product design, industrial design, everything they're working on now is going to make it into a shipping product, which unfortunately has the side detriment that everything they're working on we can't show you because they are all going to ship. So with that, those are our 4 product lines.
So this is kind of what we've been up to and where we're going. Working together with you over the last year, Apple has regained its technological lead. And we intend to keep it. So we're going to really work hard to do that. Let's work together to make that happen. That's what we have for you today. Thank you.
Before you leave,
One thing.
one small last item for those who were kind enough to stay. We get the benefit, since we kept you here for almost 2 hours, and there's 2 of us, of
We get
pulling
to
out
pick 2.
2 names.
So we spin it for, well, let's
Okay.
make sure Mitch put the cover down first.
Yeah.
There we go.
Big spin, big spin. It's locked. It's hardware, and the hardware guy's stuck. Okay,
Don't spin it too much there, Phil. You want to go first?
I'd love to go first. First winner, oh my goodness, if I can read this. I'll have to spell it. The first name is A-N-U-J, and the last name is Kapadia, K-A-P-A-D-I-A, from ICS. So if you're here, congratulations. Mrs. Rubinstein.
Oh, this one's close to home. Catherine Woods from Genentech. Congratulations.
Well, thanks again, and enjoy the rest of the conference.
Thank you, everybody.